Hello there, and welcome, wherever you are listening from a dim room, a quiet bed, a balcony overlooking the night. I'm glad you're here. Tonight, we're going to wander into a question so ancient, so gentle, and so impossibly deep that people have whispered it for thousands of years. A question small enough to fit in a child's voice, yet wide enough to swallow the entire cosmos. What lies on the other side of the universe? Not the universe as a picture in a science book, not the universe as a concept you memorized for school, but the universe as it truly is, stretching above your head right now, calm, dark, endless. As you listen, feel your breath soften. The world outside can shrink for a moment. Let your shoulders fall, let your jaw loosen, and let your thoughts slow just enough that curiosity can drift in like a tide. When you look at the night sky, it feels infinite. But of course, your eyes can only travel so far. Light must cross the darkness to reach you, sometimes for millions, sometimes for billions of years. That alone is a quiet miracle. Every star you see is sending you its past. And yet, beyond those stars, behind the galaxies, past the last photon that has ever arrived here on Earth, something continues. Something exists beyond what our eyes, our telescopes, our instruments can touch. Tonight, you and I are not here to solve the universe. We're not here to debate or to prove anything. We're here to drift, slowly, softly, through the possibilities. The universe is not a map with edges. It is a landscape with horizons, and horizons are invitations. They don't say stop, they say look deeper. So together, in this quiet moment, let's walk gently toward that horizon, toward the place where sight ends and imagination begins, where the observable universe dissolves into the unseen, where everything we know fades into everything that might be. If your eyes grow heavy along the way, let them close. Even with your eyes shut, the universe remains. And sometimes, the deepest journeys happen in the dark behind your eyelids. Let's begin. Chapter 1. The Sky That Never Ends. Step outside on a clear night, even just in your imagination, and tilt your head upward. At first, you might notice only the brightest stars, a few familiar points of light, a blue-white spark near the horizon, a soft, shimmering dot overhead, the faint whisper of a constellation you almost remember. But if you pause, if you let your eyes adjust, if you allow the darkness to settle around you like warm fabric, more stars appear, then more and more. It happens slowly, like a curtain pulling back. The longer you look, the more the sky reveals, and suddenly you realize the darkness was never empty at all. It was simply waiting for you to be still enough to see. This is the first quiet truth about the universe. The more patient you are, the more it gives. And in that giving, a strange emotion rises, a mixture of awe and confusion, and a faint, childlike question. Where does it stop? Everything in daily life has boundaries. Every road has an end. Every field has a fence. Every room ends in walls. Even our planet has an edge, a horizon where sky meets ground. So it makes sense that the human mind tries to give the universe an edge too, a border, a finish line, a place where you could, in theory, stretch out your hand and touch the outside. But the sky doesn't behave like anything else we know. You can walk to the end of a street, there's more street. You can sail to the edge of the sea, there's more sea. You can fly to the edge of the atmosphere, there's more space. No matter how far you imagine traveling, the sky refuses to end. It stretches and stretches, not like a surface, but like a depth that keeps unfolding. This feeling that the sky has no border is not an illusion. It is your mind sensing something profound. The universe is too vast to fit inside our normal sense of size. But here's the gentle twist. Even though the sky looks infinite, we cannot see infinitely far. Our sight, even with the strongest telescopes ever built, is limited not by distance alone, but by time. When you look up tonight, you are not seeing the present universe. You're seeing the universe as it once was. Light from the nearest star takes 4 years to reach you. Light from Andromeda left more than 2 million years ago. Light from the faintest galaxies left more than 13 billion years ago, long before Earth existed in any form you'd recognize. So, even the first question, where does the sky end, already dissolves into something softer. Where does light stop, and what lies beyond the farthest light that has ever reached us? There is something deeply soothing in realizing this. The visible sky, breathtaking as it is only a tiny bubble carved out by time and illuminated by ancient photons. Everything outside that bubble is real. It exists. It continues. But it is dark to us, not because it is empty, but because it has not had time to reveal itself. The sky doesn't end. Our ability to see it does. And that alone invites the next step on our journey toward the idea of something called the observable universe. A glowing sphere of everything light has had enough time to reach us. A sphere that moves with us. A sphere that expands as light travels. A sphere that is not the whole universe, only the small, precious window we can see. Before we step through that window, pause for a moment. Let your mind drift over the stars again. Let the quiet settle. Let the idea grow gently inside you. The sky is not a ceiling. It is a doorway. And tonight, we're going to walk through it. Chapter 2, The Observable Universe, Our Lantern in the Dark. Imagine standing alone in a wide, open field at night. The world around you is dark, not frighteningly dark, just softly, naturally dim. You lift a lantern, and its glow forms a warm sphere around you. Inside the glow, grass, ground, familiar things. Outside it, darkness, not empty, just unseen. The light is not a wall. It is a limit, a gentle bubble carved by the reach of illumination. This is the perfect metaphor for the observable universe. Our lantern is time, its glow is light, and the darkness beyond is not a void, only the part of existence whose light has not yet arrived. The universe began roughly 13.8 billion years ago. That means the lantern has only been shining for 13.8 billion years. In that time, light has raced outward at the fastest speed allowed, but space itself has been expanding under its feet. So, although the universe is 13.8 billion years old, the radius of the observable universe is not 13.8 billion light years. It is about 46 billion light years in every direction. This number alone is big enough to make the mind soften, like wax melting against heat. 46 billion light years in just one direction, 93 billion across. Even the number barely captures the scale. The universe is not just large, it is larger than large can describe. But here's the gentle, almost poetic twist. The observable universe is different for everyone. If you were on a planet circling a star in another galaxy, your lantern of time would carve out a slightly different bubble. Your observable universe would overlap mine, but not match it perfectly. Each point in space has its own horizon. We are all walking with our own lanterns through the same immeasurable darkness. Each lantern shows a different slice of the same reality. Within our slice, our observable sphere, we see hundreds of billions of galaxies, each holding hundreds of billions of stars, surrounded by nebulae, clusters, superclusters, arranged in filaments stretching like cosmic rivers. But beyond that glowing sphere, reality continues. Galaxies spin, stars burn, planets circle suns we will never see. Distances stretch so fast that their light cannot catch us. Not now, not ever. It is strange to accept something so enormous as both real and unreachable, but the truth is not frightening, it is calming. The observable universe is not the container of everything, it is simply the part illuminated by time. Think again of the lantern. Everything outside its glow is real, but hidden. Everything farther than the light can travel is dark, but present. And so, what we call the edge of the universe is not a physical border, it is a light horizon, a soft frontier made of time, not matter, a distance defined by patience, not space. If you journeyed through the cosmos in a spaceship, you would never feel yourself crossing this boundary. No warning, no change in scenery, no sign that you have reached the edge of the visible. The universe doesn't have edges, it has limits of perception. And that leads us naturally into the next step, the story of expansion, the discovery that galaxies are not just floating away, but that space itself is stretching constantly, everywhere. A discovery that reshaped everything we know. Chapter 3, Expansion, the universe that keeps stretching. Imagine holding a small balloon in your hands, its surface covered with tiny ink dots. As you blow air into it, the balloon expands and every dot drifts farther away from every other dot. Not because the dots are moving, but because the surface beneath them is stretching. This simple picture captures one of the most important and most soothingly strange truths in all of cosmology. Galaxies are not flying through space. Space itself is expanding. This idea began quietly in the early 20th century, with astronomers studying the light of distant galaxies. They expected to find some drifting toward us and some drifting away, a natural mix of motions. But what they found was startling. Almost every distant galaxy was moving away, and the farther it was, the faster it retreated. Their light was stretched, shifted toward the red end of the spectrum. This redshift was the universe whispering a secret. Space is growing. When Edwin Hubble compiled these observations, he realized something profound. Expansion wasn't random, it was universal, smooth, everywhere at once. It meant the universe had not always been like this. It must have once been smaller, denser, hotter. This insight led to what we now call the Big Bang, not an explosion in space, but the beginning of space itself. But here's the gentle twist. Expansion never stopped. Every second, the fabric of the universe stretches a little more. Not enough to pull atoms apart, not enough to separate you from the planet beneath your feet, but enough to send galaxies drifting, like lanterns, floating down a slow, calm river. Everything far away moves farther away. Even farther things move faster still. No place is the center. Every place is the center. Every galaxy sees the same pattern. This is one of those cosmic truths that feels like a riddle. The universe has no center because everywhere is expanding at once. Imagine standing on a raisin inside a loaf of rising bread. As the dough expands, every raisin sees all the other raisins drifting away. None of them occupies a privileged position. This is our cosmos. And yet, the story becomes even stranger and somehow more beautiful. For decades, scientists assumed something intuitive. If expansion began long ago, then gravity should be slowing it down. Galaxies tug on each other, clusters pull on clusters. Surely, over billions of years, This tug of war must reduce the rate of expansion. But then came a discovery that changed everything. The expansion was not slowing down. It was speeding up, as if the universe were taking a deeper breath, stretching faster with time, as if something invisible were pushing space apart. We call this something dark energy, a name that captures our lack of understanding more than it explains the phenomenon itself. Dark energy is not energy like starlight or heat. It is not stored in particles or fuels or fields we can touch. It is woven into the fabric of space. Wherever space exists, dark energy exists. And where dark energy exists, expansion accelerates. This means that over unimaginable timescales, more and more galaxies will drift beyond our reach. Their light will thin, redden, and eventually fail to reach us at all. Not because those galaxies vanish, but because space between us grows faster than their signals can cross. There is something quietly heartbreaking and quietly serene about this. We live in a cosmic moment of rare visibility, an era when light from distant galaxies still arrives, still speaks, still tells us where we are in the grand structure of things. Future beings, billions of years from now, may look up at a far quieter sky, a sky with fewer lanterns, a sky where cosmic expansion has dimmed the universe into spacious solitude. And yet, this very expansion, the stretching of everything, is what allows us to ask tonight's question. If everything is stretching, if space itself has no center, if the horizon is defined by time rather than walls, then what truly lies beyond? To answer that, we must go beyond expansion itself to the horizon it creates, a horizon we can never reach, yet one that moves with us like a soft, cosmic boundary. Chapter 4: Dark Energy and the Accelerating Future. Try to picture the universe long ago, not with your eyes, but with your mind. Billions of years before Earth formed, before the sun even existed, the universe was younger, denser, and closer together. Galaxies nestled more tightly. Star clusters crowded the cosmic landscape. Light did not have as far to travel between one place and another. In that early universe, expansion was already underway, gentle at first, then steady. Scientists once believed this expansion behaved like a car rolling up a hill, slowing gradually, pulled back by gravity, perhaps even destined to stop entirely. This seemed reasonable. Gravity pulls everything together. Why should the universe be an exception? For decades, astronomers tried to measure this slowing. They studied distant supernovae, exploding stars that shine with predictable brightness, hoping to see signs that galaxies long ago were moving apart more slowly than they are now. But the universe surprised them. The supernovae were fainter than expected, not because they were small or weak or obscure, but because they were farther away than they should have been. This meant only one thing: the universe isn't slowing down, it's speeding up. Like a traveler on a dark road suddenly breaking into a run, the fabric of space is stretching faster and faster with time. The more distant a galaxy is, the more severely its light is stretched, so much so that some galaxies are already moving away from us faster than light, not because they break physics, but because space itself is lengthening beneath them. To explain this odd, accelerating behavior, scientists introduced a term: dark energy. The name doesn't describe what it is. It simply notes what it does, pushing, gently, constantly, everywhere. Dark energy permeates the universe in a strange, even way. It does not clump into stars or planets. It does not gather into galaxies. It is the same in every direction, in every void, in every intergalactic stretch of darkness. Wherever space is, dark energy is. And wherever dark energy is, expansion accelerates. We do not know its nature. We cannot bottle it, detect it directly, or hold it in an instrument. But we can feel its fingerprints all across the cosmos. Galaxies drifting faster apart than gravity allows us. Light stretched into deeper red. The large-scale structure thinning as space swells. Dark energy now makes up nearly 70% of the entire energy content of the universe. Everything you see, stars, galaxies, nebulae, the whole shining cosmos, is the minority. Matter is only a small note in a much larger cosmic symphony. And here is the soft, profound implication. The universe is growing beyond our ability to keep up with it. Today, we still see thousands of galaxies at the edge of the observable universe. Their light arrives faintly, stretched by unimaginable distances, but it arrives. Far in the future, that will no longer be true. Those galaxies will drift beyond our cosmic horizon. Their light will thin, redden, and eventually fail to reach us altogether. To future observers, if any exist, the night sky may appear lonely. Perhaps only the local group of galaxies will remain visible, the Milky Way, Andromeda, and a handful of small companions. Imagine that future sky. No distant clusters, no cosmic web stretching across billions of light years. No faint whispers from galaxies long gone, just a quiet island of stars floating in a dark, expanding sea. It sounds sad at first, almost melancholic, but there is a peacefulness to it as well, the quiet settling of a universe in its late twilight. And most extraordinary of all, we live in a rare moment where the universe is still open, visible, and rich with distant light. We are here during the brief era, a few cosmic heartbeats when the cosmos reveals itself. The light from faraway galaxies is still in transit. Their ancient photons still wash over us. Their histories still reach our instruments and our eyes. We are witnesses to a sky that future civilizations may never see. This alone makes our place in time feel special, not privileged, but meaningful. Like candles lit during the fading dusk, we stand in a window of visibility that nature will one day close. But even as expansion accelerates, a deeper question rises. If the universe is pushing everything apart ever faster, what does that mean for the horizon of what we can see? And so we step forward into the next chapter, toward the very boundary between the known and the unknowable. Chapter 5, The Cosmic Horizon, a line we can never cross. Stand on a beach and look out to sea. The horizon is not a wall. It is not a boundary, not a cliff, not the end of the ocean. It is simply the limit of what your eyes can reach, the farthest place light can travel to you before the curvature of the earth hides the rest. The cosmic horizon works the same way. It is not the edge of the universe. It is the edge of the observable universe, a boundary drawn not by matter, but by time itself. Imagine the universe as a vast ocean. Your eyes and our telescopes are boats floating on its surface. The cosmic horizon is the circle of sea your light can reach before fading into the dark beyond. This horizon sits about 46 billion light-years away in every direction. That means that even though the universe is only 13.8 billion years old, its visible radius is far larger because space has been stretching as light travels through it. Think of it like this. If you shine a flashlight into a stretching hallway, the light takes longer to reach the end because the hallway is pulling away while the beam moves forward. Light from distant galaxies has faced this stretching for billions of years, and because the universe expands as light travels, the distance between us and those galaxies is now much greater than the time it took their photons to begin the journey. The cosmic horizon is the final frontier of what we can ever observe, not because telescopes are weak, not because our eyes are limited, but because light requires time, and time has boundaries. Beyond the horizon, light simply has not had enough time to arrive, and because expansion is accelerating, some regions will never send us light. Even if we waited trillions of years, even if we built telescopes the size of galaxies, the physics of the universe would prevent us from ever seeing them. This leads to a truth that feels soft and humbling. The universe extends far beyond the part we can observe, maybe infinitely, but only a fraction is reachable. Inside our cosmic horizon, galaxies, clusters, superclusters, filaments of glowing gas, ancient starlight still wandering toward us. Outside, galaxies still forming, stars still burning, worlds still turning, maybe life, maybe civilizations, maybe cosmic structures beyond imagination, but their light will never find us. The universe does not hide them deliberately. They are simply too far away, and expansion too fast. If you could somehow fly toward the cosmic horizon, you would never reach it. Like the horizon on Earth, it moves as you move. It retreats endlessly, always just beyond your grasp, a boundary that follows you, a line drawn not in space, but between visibility and invisibility. This makes the cosmic horizon one of the most poetic concepts in all of science. It marks not the end of the universe, but the end of knowledge. The sky beyond the horizon is still real, still vast, still full of galaxies and matter, yet permanently unreachable. And that is strangely comforting, because it means the universe is not a small room with walls. It is a landscape so large that no observer can ever see all of it. Every being, every civilization anywhere in space has its own horizon, its own bubble of visibility carved by time. Each bubble overlaps with others, forming a cosmic mosaic. Together, these overlapping spheres connect the whole universe, even though none of them can capture it all. The cosmic horizon is a gentle reminder that mystery will always exist. There will always be more beyond our sight, beyond our reach, beyond what we can measure. And that mystery is not a flaw in science, it is a feature of reality. But the horizon invites another deeper question. If the universe doesn't end at the horizon, then what does the universe look like on the other side? To explore that, we must look backward in time to the very first light that ever escaped and to the ancient glow still surrounding us. Chapter 6, The Baby Picture of Everything, the Cosmic Microwave Background. If you could travel backward in time, not decades, not centuries, but billions of years, the universe would appear stranger and stranger the deeper you went. Stars would disappear, galaxies would dissolve, nebulae would shrink into dense clouds, space would grow hotter, brighter, more crowded, and eventually you would reach a moment when the universe was so dense, so fiery, so tightly packed that light itself could not move freely. It would be like standing inside a cloud so thick that no beam could pass through. In that early universe, everything glowed but nothing could shine. And then, about 380,000 years after the Big Bang, a quiet transformation occurred. The universe cooled just enough for electrons and protons to join into atoms. Suddenly, light was free, like releasing a billion trillion lanterns into the sky at once. That ancient light has been traveling ever since. For 13.8 billion years, it has crossed a universe that expands beneath it. And as space stretched, the light stretched to fading from brilliant fire into a gentle, cold glow. Today, that glow is everywhere. in every direction, on every patch of sky. A thin veil of microwave radiation, the cosmic microwave background. If the observable universe has a wall, this is it. Not a solid wall, not a barrier, but the farthest moment we can ever see backward in time. Beyond it, the universe was opaque. We cannot see earlier than this moment with ordinary light. When scientists map this glow, they see slight variations in temperature, tiny ripples, only a few millionths of a degree. But those ripples are not random. They are the fingerprints of the early universe. Little hot spots where matter was slightly denser, little cold spots where matter was slightly thinner. Over billions of years, gravity magnified those tiny differences. The dense spots became galaxies, clusters, superclusters. The thin spots became the voids between them. Those delicate ripples are the seeds of everything, every star, every planet, every atom in your body. This is why the cosmic microwave background is often called the baby picture of the universe. Not just metaphorically, quite literally, it is the earliest light the universe ever released, still arriving here today. Imagine opening an album and seeing the first photograph ever taken of reality, a picture from when the universe was barely out of infancy. That's the CMB. But it teaches us something even deeper. The universe is remarkably uniform, smooth, balanced. How could opposite sides of the universe so far apart they could never have exchanged light or heat look almost identical in temperature? This puzzle led to one of the greatest ideas in modern cosmology: inflation, a moment of sudden, violent expansion that smoothed the early universe before it grew large. The CMB is evidence of this smoothing, a whisper that long before galaxies formed, the universe inflated so rapidly that tiny regions ballooned into cosmic expanses. And yet, despite this uniformity, the CMB also reveals the earliest fractures, the first hints of structure, the first hints of diversity in the cosmic landscape. Those ripples, those faint patterns, are like the earliest brushstrokes of existence. Everything that came after stars, galaxies, planets, oceans, life sprouted from variations barely thicker than a whisper. Looking at the CMB is looking back as far as light allows. It is the true boundary between the bright universe and the shadowed one behind it. Beyond it lies time we cannot see, events we cannot measure, moments too dense and too hot for light to record. This creates a second kind of horizon, a temporal horizon. One side contains all of cosmic history we can observe. The other side contains everything earlier, the unlit pages of reality. And to understand what might lie beyond the universe as we see it, we must consider these horizons not as obstacles, but as gentle reminders. There is always more time behind us, more space beyond us, more existence outside the bubble of what light can reveal. It is here, standing at the boundary of the cosmic microwave background, that the real question begins. If this is only the earliest we can see, what shapes, structures, or possibilities lie beyond visibility itself? Chapter 7: The Unobservable Universe. Forest beyond the fog. Imagine walking through a dense, early morning forest. The trees closest to you are crisp and detailed. You can see the patterns on their bark, the shapes of their leaves, even the thin moss stretching across their roots. A little farther away, the trees soften. They fade into silhouettes. The details dissolve into mist. Keep walking, and eventually the fog becomes so thick that the forest continues, but you cannot see it anymore. Not because the forest ends, but because the fog hides what is real. This is the perfect metaphor for the unobservable universe. The observable universe, our cosmic bubble, is just the part of the forest we can see through the fog. Everything beyond that horizon is still part of the same cosmic forest, still real, still filled with galaxies, stars, light, matter, and possibly life. But their light has not reached us, not yet, and because of accelerated expansion, not ever. The distances are simply too vast. Space is expanding too quickly. Some galaxies are receding faster than their photons can travel toward us, like boats being carried away by a strong tide faster than their paddles can pull them back. When you look up at the night sky, you are seeing only a fraction of the universe, a tiny glowing island in a sea that stretches far beyond imagination. Scientists estimate that the unobservable universe may be hundreds, thousands, or even infinitely times larger than the observable one. And here is the gentle truth. There is no reason to believe the universe ends where our vision ends. Galaxies do not stop. Cosmic structures do not suddenly vanish. The cosmic web does not fray into nothingness. The universe almost certainly continues outward, just as the forest continues through the fog. If your eyes could collect light infinitely fast, if light could outrun expansion, you would see galaxies far beyond our horizon, superclusters, impossibly distant cosmic structures that formed separately from our own prose, regions of space never connected to ours, stars whose photons will never cross the gap, perhaps even entire island universes with their own unique histories. But because the universe is young compared to its size, and because expansion grows faster with time, much of reality is permanently hidden, not invisible, just unreached. There is a kind of cosmic loneliness in this, a softness, almost melancholy, like standing on a shore and knowing there are continents across the ocean that you will never see. But there is comfort too, because the unobservable universe is a reminder that existence is richer than perception, that reality does not depend on our ability to witness it, that we are part of something vast enough to exceed the limits of our senses. Every point in space has its own observable bubble, its own glowing sphere defined by the reach of light. If you could teleport to a distant galaxy, your cosmic horizon would shift. You would see a different part of the universe. Your bubble would overlap ours, but not match it perfectly. The universe contains countless overlapping bubbles like lanterns floating in an endless dark sea. Each reveals a slice of reality. None reveals all of it. Yet together, they cover the whole. This leads to one of the softest, most profound realizations in cosmology. We will never see the entire universe, but the universe holds far more than we need to feel wonder. As we move forward, a deeper question emerges gently, like a branch appearing through the mist. If the observable universe is just a bubble, what is the shape of the whole? Does it end? Does it loop? Is it infinite? To explore that, we must step into a concept stranger than infinity, the idea of space that is finite but has no edge. Chapter 8. Does the universe ever end? Infinity versus loops. Let's begin with a deceptively simple question. Does the universe go on forever? The intuitive answer, shaped by childhood, by imagination, by the feeling of staring into the night, is yes, probably. But the deeper truth is far more subtle and far more comforting. There are two great possibilities. Possibility 1, the universe is infinite. Infinite space, infinite galaxies, infinite stars, infinite versions of cosmic history, perhaps even infinite versions of you, separated by distances so immense they cannot influence one another. In an infinite universe, every possible arrangement of matter occurs somewhere. Every pattern repeats. Cosmic history becomes a grand tapestry woven endlessly outward. But infinity, while beautiful, can feel overwhelming. Endless space is hard to imagine, hard to emotionally hold, which is why we also consider a second possibility. Possibility 2, the universe is finite, but unbounded. This is one of the most soothing and elegant ideas in physics. A universe that is finite in size, not endless, yet has no edge, no wall, no border, no outside. How can that be? Think of the surface of the earth. It is finite, you can measure it, map it, hold a globe in your hands. But if you travel in one direction long enough, you never encounter a boundary. You simply circle back to where you began. The earth's surface is finite, but unbounded. Now imagine that idea in 3 dimensions. Space itself might loop around in a shape far more complex than a sphere, a 3-dimensional torus sphere, a curved hypersphere, a multi-connected topology, or something stranger than human intuition can grasp. In such universes, you could travel in a straight line forever and never reach an edge. You might, after unimaginable time, return to your starting point from the opposite direction. Patterns in the cosmic microwave background might reflect this looping architecture. In a finite, unbounded universe, there is no outside. The universe does not need a container. It is its own geometry. This possibility is deeply soothing in a sleepy science way. We are not floating in an infinite void. We are inside a cosmic shape, a shape so large and so gentle that we cannot detect its curvature with current instruments. And current observations? They show that the universe is extremely close to flat, so flat that if it curves, the curvature is far too subtle for us to measure. Yet, a flat universe can be infinite. A flat universe can also be finite with complex topology. Both options remain open. But whichever is true, one truth emerges softly. The universe has no hard edge, no cliff, no border, no outer boundary where existence stops. Instead, it has horizons, horizons of light, horizons of time, horizons of curvature, horizons shaped by expansion, and beyond those horizons, the universe finite or infinite continues. This realization evokes a strange emotional symmetry. If the universe is infinite, we are tiny but part of an endless whole. If the universe loops, we are travelers inside a cosmic architecture we may never fully see. Either way, there is no edge to fall from, no boundary to fear, just the gentle continuation of existence. But if space can be flat or curved, if it can loop or stretch, then what gives space its shape at all? To answer that, we need to follow the fabric of the universe back into its source, the geometry of space-time itself. Chapter 9. The shape of everything. Flat, curved, and strange. Let's imagine space not as an empty container, but as a living fabric, soft, flexible, and responsive. A fabric that bends, a fabric that stretches, a fabric that can curve around stars and swirl around black holes. This idea came from a quiet revolution in thought, Einstein's general theory of relativity. Before Einstein, gravity was seen as a force pulling objects together. After Einstein, gravity became something deeper and far more poetic. Matter tells space-time how to curve, and space-time tells matter how to move. Imagine placing a heavy ball on a rubber sheet. The sheet curves. Roll a small marble across the surface. It spirals inward, following the curve. In our universe, the rubber sheet has not just 2 dimensions, but 4, 3 of space, 1 of time. Stars, planets, galaxies, all press into the fabric, shaping its geometry. Light follows the curves. Time itself slows or speeds depending on the depth of these cosmic depressions. This curvature creates everything we observe: orbits, gravitational lenses, the bending of starlight, the stretching of time, even black holes themselves. Now, when scientists speak of the shape of the entire universe, they are asking, how does space-time curve on the largest possible scales? There are three broad possibilities. 1. A flat universe. This means space-time is not curved overall. Parallel lines stay parallel. Triangles behave as they do on a flat surface. The sum of angles is 180 degrees. A flat universe can be infinite or finite with tricky topology. Current measurements suggest our universe is extremely close to flat. If there is curvature, it is subtle beyond our current reach. 2. A closed universe. Here, space-time curves like the surface of a sphere, except in higher dimensions. Parallel lines eventually meet. The universe is finite but unbounded. Travel far enough in a straight line, and you may return to where you started. 3. An open universe. This space curves like a saddle. It expands forever, with no looping or closure. This would mean an infinite universe with negative curvature. But beyond these broad categories, geometry can become deeply strange. The universe may have a topology with twists, with identifications, with multi-connected passages, with repeating patterns, or with edges connected to other edges like a cosmic video game map ace. Some shapes allow light to wrap around and create ghost images of galaxies. Some allow space to repeat. Some even allow for shapes we cannot visualize with three-dimensional intuition. But here is the gentle part. No matter the shape, the universe has no sharp boundary. Curvature does not create walls. It creates pathways. It tells galaxies how to move. It shapes the cosmic web. It sculpts the large-scale structure we see in surveys: threads, clusters, voids. Gravity, through curvature, paints the architecture of the cosmos. And yet, the same curvature also creates hidden worlds, regions where space-time bends so deeply that not even light can escape. Black holes, wormhole solutions, gravitational warps. Geometry becomes destiny. But between these curves lies a deeper mystery, a question that emerges softly from the folds of space-time. If space can curve, stretch, fold, and loop, could it also hide regions we can never access, places where geometry becomes a doorway rather than a wall? To answer that, we must step into the realm of the universe's hidden destinations, the places where curvature grows so intense that paths split, horizons form, and the map of reality becomes something more like a story. Chapter 10. Hidden Destinations, Black Holes, Lensing, and Possible Wormholes. In the great quiet of space, not everything is gentle. Some places are so heavy, so dense, so deeply curved that space-time folds into wells no light can climb out of. Yet even these places, black holes, gravitational lenses, hypothetical wormholes, have their own strange, soft beauty. They are not violent in the way we imagine storms or explosions. Their power is silent, mathematical, inevitable. When you hear the words black hole, you might picture a cosmic monster, something hungry, devouring everything nearby. But in truth, a black hole is simply an extreme curvature of space-time, a place where geometry bends so deeply that paths no longer lead outward. Imagine a river flowing toward a waterfall. Upstream, the water moves slowly. Near the edge, the current grows faster. At a certain point, no matter how hard a fish swims, it cannot escape the pull of the waterfall. This is how light behaves near a black hole, far from the center, Light curves slightly. Closer in, it bends sharply, and at a certain radius the event horizon, even a photon moving at light speed, can no longer climb away. Not because gravity grabs it, but because space-time itself is flowing inward faster than light can swim upstream. Inside the event horizon, all paths lead inward. Time and space exchange roles. The center becomes not a place you fall toward, but a moment you fall into, a moment in your future, unavoidable. But black holes are not merely endpoints. They also act as lenses, bending the fabric of reality so strongly that they warp the appearance of stars behind them. A massive galaxy cluster can distort light from more distant galaxies into glowing arcs and halos. To a telescope, these arcs look like smears of light, but they are the stretched images of galaxies far beyond. In this way, black holes and dense regions of space-time act like cosmic mirrors. They reveal what lies behind them by bending the very space light travels through. But the strangest possibilities arise when we follow the mathematics deeper. Einstein's equations allow solutions describing tunnels, shortcuts between distant regions of space-time. We call them wormholes. They may not exist in nature. They may be unstable, collapsing instantly. They may require exotic matter to remain open matter with properties we do not yet know how to create. But the equations allow the idea. A wormhole would be like folding a sheet of paper so that two distant points touch. A line drawn from one point to the other would be long, but if the sheet folds, the distance shrinks to almost nothing. Space might be able to do the same. If wormholes exist, even if they form and vanish too quickly to pass through, they would be hidden destinations within the geometry of the universe. Places where distance stops behaving like distance, where far away might briefly become right here. But whether or not wormholes are real, the underlying truth remains. Curvature creates destinations we cannot see, horizons we cannot cross, regions forever hidden behind the fabric of space-time. Black holes are not the only horizons in the cosmos. Every observer has a cosmic horizon. Every point in the universe has a region of space it can never observe. These hidden destinations, black holes, unreachable galaxies, horizon-shrouded regions, are reminders that the universe is not a simple, open map. It is a terrain with folds, boundaries, and unreachable depths, a landscape of visible and invisible storylines. And as strange as black holes are, there is something even stranger waiting beyond them, the possibility that our universe is only one bubble in a vast foam of realities. To approach this idea, we must gently step into the realm of the multiverse. Chapter 11. The multiverse. Other bubbles, other rules. When people hear the word multiverse, they often imagine science fiction portals, parallel worlds, alternate selves. But the scientific idea of the multiverse is far more subtle and in many ways more beautiful. It begins with a moment at the dawn of time. Right after the Big Bang, the universe underwent a brief but extraordinary phase called inflation. Space didn't just expand, it ballooned at a speed faster than light, stretching quantum fluctuations into cosmic scale structures. But according to many models, inflation never ended everywhere. It ended in pockets, bubbles, while the rest of space continued inflating. Each bubble became its own universe. Our universe is one such bubble. Elsewhere, beyond our cosmic horizon, other bubbles may exist, each with its own physical constants, each with its own geometry, each with its own timeline. This picture is sometimes called eternal inflation, a cosmic foam endlessly growing, endlessly budding. If this is true, then everything we see, all the galaxies, all the stars, All the cosmic web is just one patch of a far larger cosmic quilt. Our bubble may even collide with others, leaving faint scars in the cosmic microwave background. Scientists search for these imprints, though none have been confirmed yet. But inflation is not the only idea. Quantum mechanics offers its own version, the many worlds interpretation. Every time a quantum event has multiple possible outcomes, reality branches, creating separate, coexisting histories. Not because the universe splits like wood, but because the mathematics includes all possibilities simultaneously. In many worlds, there is no collapse of the wave function. There is only branching. Every choice you make, every particle that shifts, every interaction, each one produces a version of reality in which one outcome happened and another version where a different outcome unfolded. This is not a mystical idea, it is simply one mathematically consistent way to interpret the equations of quantum physics. Then there is the string landscape, arising from string theory. It proposes that fundamental particles are tiny vibrating strings, and the universe contains many possible shapes for extra dimensions. Each shape creates a different set of physical laws: gravity, strength, particle masses, even the number of forces. The number of possible vacuum states may be so large, 10, 500 or more, that each corresponds to a different universe. All three ideas, eternal inflation, many worlds, and the string landscape, share a common theme. Our universe might not be the only one. It may be one chapter in a much larger book of reality. But here is the gentle, grounding truth. We cannot reach these other universes. They do not affect our own bubble. Their light will never cross our horizon. They exist, if they exist at all, as part of a grander structure, far beyond human access. And yet, the possibility itself is comforting. It means that reality is deeper than we can see, that nature has room for variety, creativity, and endless expression, that our universe, with its delicate balance allowing stars, chemistry, life, consciousness, is not a lone miracle, but one pattern among many. This idea softens a profound question. Why does our universe allow us to exist at all? In a multiverse, the answer is gentle. We live in this universe because it is one of the places where life can arise, not because it was designed for us, but because out of countless possibilities, at least one would inevitably produce observers. And yet, even the multiverse does not answer everything. Beyond the bubbles, beyond the branches, beyond the landscapes of higher dimensions, there remains a limit we cannot cross, a limit not of physics, but of meaning. To explore that, we enter our final chapter, Chapter 12, Parallel Realities and the Gentle Limits of Knowledge. There is a moment, usually late at night, when the world feels quieter than usual, when thoughts move slowly, softly, as if wrapped in velvet. This is the perfect moment to ask a final question. What does it really mean that parts of the universe are beyond our reach? We often imagine understanding the universe as a kind of conquest, building bigger telescopes, sending faster spacecraft, collecting more data, until finally we know everything. But the truth whispered by the cosmos is tender and humbling. Some things are meant to remain beyond us, not because the universe is hiding them, but because the structure of reality includes horizons that no observer can cross. Every galaxy has its own horizon. Every point in space has limits on what it can see. Every observer experiences a version of the universe shaped by the light that reaches them. And yet, despite these boundaries, we all belong to the same cosmic story. Whether the universe is infinite or loops, whether other bubbles exist or not, whether quantum branches form parallel realities, None of these possibilities diminish our experience here. If anything, they enrich it, because they reveal a truth deeper than any measurement. We are part of something vast enough to hold endless mysteries. Not everything needs to be solved. Not everything needs to be fully known. Mystery itself is part of the beauty. Imagine lying on your back beneath a clear night sky. Above you, stars shimmer like frost on black glass. Behind them, galaxies glow softly. Behind those galaxies, entire stretches of space you will never see. Behind that, regions of the universe beyond your horizon. And behind even that, perhaps other universes, other histories, other versions of reality. You do not need to see all of it for it to be meaningful. The universe does not become smaller just because we cannot grasp it all. Instead, it becomes more profound. Your place in it becomes softer, quieter, more intimate. You are not outside the story. You are inside the only part of it that allows you to feel wonder. Here, now, breathing, listening, drifting towards sleep with the gentle awareness that the cosmos is both incomprehensibly vast and profoundly connected. Somewhere far beyond our observable bubble, light is traveling from stars we will never witness. Somewhere even farther, space-time may curve into shapes we cannot imagine. Somewhere beyond all horizons, the multiverse might unfold like a book with infinite pages. And yet, here you are, experiencing this one chapter, the chapter where stardust learned to contemplate the stars. Perhaps that is enough. Perhaps the purpose of these mysteries is not to be solved, but to remind us that being alive in this universe is already a miracle. And as the night grows quieter, as your mind softens, as your breath deepens, you can let the infinite rest for now. The universe is still expanding, still unfolding, still full of stories beyond the horizon. But for this moment, all you need to do is rest inside your small, glowing corner of it. The only universe you can touch, the only one you can feel, the only one your heart knows. Let the mystery hold you. Let the night carry you. Let the cosmos hum softly in the background as you drift, slowly, peacefully, into sleep.